So the purpose of today is to introduce how to solve a two-step equation. At the beginning or end of last week, we started looking at one-step equations, and we looked at them briefly. In those situations, you are just undoing or finding the inverse operation of just one operation. So we reviewed that the inverse operation of addition or positive is subtraction. The inverse of subtraction is addition. Multiplication, the inverse is division, and then division, the inverse is multiplication. And you're doing something to each side of an equation to keep it equal, but your main goal is to isolate the variable. So we're going to see what that looks like today, but this time each of our equations are going to involve two steps. So I have a little process for you. This will be the beginning of your notes if you write this up at the top. Just a couple steps just to think about as you go through solving a two-step equation. And so if you could write these down in your notes. The first one is exactly the same as the first step when solving a one-step equation. And that step is to first isolate the variable. Whatever the unknown piece is, when I have to isolate a variable, I always circle it just so that my eyes are really drawn to it. So that would be the first goal, is to isolate the variable. And in this case, because there's two operations, this variable is always going to have a coefficient with it. And remember, we defined a coefficient as a number that's either multiplied or divided by a variable in the beginning of our expressions unit. So really, when you isolate a variable, you're isolating a variable and the coefficient that's with it. Then your second step will always be to undo either the addition piece or the subtraction piece first. In most cases, there will only be one or the other of these, so your job will be to identify which one you need to undo and accomplish that before you accomplish the undoing, which is step 3 of multiplication or division. But it's really important that this gets done first, because really you're kind of doing a backwards order of operations, or a backwards PEMDAS. So because addition and subtraction happens at the very end of PEMDAS, when we work backwards, that's the first thing that we need to undo. So really, if we can follow these 3 steps, I don't think we'll have any issues in solving these equations. So let's jump right into a couple examples, and I'll have you do some on your own. So example number 1 looks like this. We have -3 plus x divided by, remember we're always going to see that as a fraction now, divided by 4 equals 73. So we're going to first isolate the variable and the coefficient. In this case, the coefficient is a divisor. I like drawing that line just to make it simple. And so our first step then is to get rid of the addition or subtraction piece. In this case, we need to get rid of this -3. In order to get rid of it, really, we're trying to get it back to 0 to cancel it out. So to cancel out or get to 0 and -3, I need to add 3, which means I need to add 3 to this side. And with the two-step equation, I always like to draw a line after that first step is done, really just to keep myself organized. I think it's a great tool, especially when we move into 3-step equations and beyond. This really helps keep you organized as you work down the page. So these 3's are going to cancel out. We're now going to be left with our x divided by 4, and then 73 plus 3 gives me 76. That equal sign is just going to carry down. Now we just need to isolate that x by itself. It's currently being divided by 4, so to undo that, I need to multiply by 4. I'm using that little dot there to represent multiplication, which means I also need to multiply the other side by 4. That will cancel these 4's out, making it just the one x we want, and then 76 times 4 gives me x equals 304. And then again, just to refresh, we can always plug that back up here into the original equation and then solve. So if I take 304 and divide it by 4, I get 76. And if I add that to a -3, I get my 73, which was the original answer. So just an easy way to check yourself every single time. So let's jump back in then to example number 2. I have this equation x divided by -5 plus 2. So again, I'm going to circle the variable and the coefficient. I'm going to draw my line down to really draw my attention to this other piece that's in the way of getting x alone. In order to undo that plus 2, I need to subtract 2 to get that to 0, which means I need to do that to the other side. Draw my line to complete my first step. My 2's now cancel out. I'm left with x divided by -5. and 82 minus 2 leaves me with 80 on the other side. Then step 2 will be just to get this x alone. Again, I'm undoing the division. It's division by -5, which means I need to multiply by -5, exactly what's there, which means I need to multiply this side by -5. Now I'm left with my 1x on the side by itself, and 80 times -5, positive times a negative is a -400. Again, we can plug that back in to just double check. -400 divided by 5 gets me 80, add 2, and I get 82. So example 3, now we're going to move into some multiplication that we have to undo. Those first two, we had division in the equation. Now we see multiplication. So I'm going to start the same way by circling the coefficient and my variable, draw my line down, because now it's very clear that I need to get rid of a plus 8. And to undo that, I need to subtract 8 to get me 0, which means I'm subtracting 8 on this side. Draw my line just to organize myself. That's the end of step 1. 8 minus 8 leaves me just with that minus 3x, which is what I want left. And 104 minus 8 leaves me with a 96 over on this side. So now for step 2, I'm undoing the multiplication or division piece. I can just circle the variable I want alone. That's currently being multiplied by -3. So to undo that, I need to divide by a -3 to cancel that out and just get my x. -3 divided by -3 is just 1, which gives me 1x. But then I need to divide my 96 also by -3 to get me that x equals 32, -32, because we have a positive divided by a negative. Again, we can plug that back into x, just trying to show you just how easy it is to make sure that your answer is correct. 3 times 32 gives me 96. -3 times -32 is a positive 96, plus 8 is 104. Final example I'm going to do with you before you try a couple on your own. We get -12 plus 7x, and again that plus sign goes with the 7. We talked about that in our expressions unit. I'm trying to get that alone. So the first thing I need to get rid of is this -12. I do that by adding 12 to get me to 0, which means I have to add 12 to the other side. So now I have my positive 7x alone on one side, and I have 154 over on the other side. So now in order to get x alone, it's currently being multiplied by 7. So I need to divide by 7 to undo that, which means I need to divide the other side by 7, and I get x equals 22 as my final answer, which I again am just going to plug in one last time to double check myself. 22 times 7 is 154, and if I add a -12, that gets me that final answer of 142. So really, as long as we can remember that we have to undo that addition or subtraction piece first, before we undo the multiplication or division, it has to go in that order. So I'm going to give you 2 more I'll put up here. I want you to pause the video and try them, and then you can unpause and just check in to see how you did. So here's the 2 that I'd love for you to try on your own. We see one division example as well as a multiplication example, just so that we could see how you do. Just a reminder that remember that this negative sign goes with the 16 over here. I'm going to circle that for you just because that's the mistake that I'm assuming most people will make. So pause the video, see what you can do on your own. So hopefully you worked through these 2 problems. For that first equation, I had to undo that plus 2 first, and then undo the division by -5. I got a final answer of -16. And then again, you can plug that back in, obviously, to the original equation. And as I'm realizing right now, you can tell that even I made a mistake here because I took 80 and divided it by -5 over here. And as I'm explaining now, can just again realize the mistake that I made. So I need to go back and I multiplied 80 times 5 to get a final answer of -400, which makes a lot more sense when you plug that back into the original equation. -400 has to be divided by -5, which is 80, then you may add 2. So again, just the importance of plugging back in and making sure your answer makes sense will save you a lot of misery in the end of this process. And then here with example number 2, I had to get rid of that positive 34 here first by subtracting 34 from both sides. And then I was left with, and again, that negative sign is brought down, that minus sign is with the 16. So I have a minus 16x equals 376. And when I divide both of those by 16, I get negative 23.5. And it must stay that half because, again, as you plug this back in to check your answer, if you round that up to negative 24 or down to negative 23, this equation is no longer going to be equal. So especially in the circumstances of equations, we can never round, always keep those decimals. So there's our little lesson on two-step equations. At this point, you may move on to the next thing on our agenda. Thanks.